All right, good morning. Welcome back to trigonometry. So here we are. We are going to talk about the trigonometric ratios. Let's go ahead and do that. So each of these ratios is a specific ratio between two sides of a triangle. And we're just going to talk about the fact that we have the sine, which is spelled S-I-N-E, but we're going to abbreviate it as sine. And then what I'm going to do is I always give it a name. Okay, so let's go ahead and let's think about we're working on a triangle. Okay, and we'll just go ahead and we'll say this is a 3, 4, 5 triangle. Okay, it's a very standard triangle. It's a right triangle. We can tell this because we know that 3 squared plus 4 squared is equal to 9 plus 16, which gives me 25. When I take the square root of 25, we end up with, we have our a squared plus b squared equals c squared being 25, so c must be 5. It's a length, so it's going to be positive. So very standard triangle. I'm going to go ahead and look at, this is my eyeball, look at this angle right here. All right. And then what we're going to do is we're going to say, okay, our sine, and I'm going to name it theta. Okay. Our sine of theta, and we're going to say that's the opposite. So you're looking at the angle, you're saying across the angle, across the way, there's my opposite side. So that's going to be defined as the opposite side over the hypotenuse side. The hypotenuse is always opposite what the right angle is. Okay, so if you're ever wondering, like, which one is hypotenuse? You find the right angle, you look across from it. Okay, if it's not, doesn't have a right angle, doesn't have a hypotenuse. Okay, the cosine, okay, and don't get too hung up on the co parts of it. It just means the coterminal angles, but that is the adjacent over the hypotenuse. So that's going to be the adjacent over the hypotenuse. Okay, and then we have the tangent, which we abbreviate TAN. And again, notice I'm always putting a theta, or I'm putting something that's the tan of something. I wouldn't just write a square root and just leave it there. It's like you don't do that. You put something in the square root so people know you're trying to evaluate something. So tangent is the opposite over adjacent. So we're going to say this is opposite over adjacent. And all we're going to do is read off these values. So opposite over hypotenuse, we're going to say, okay, that is going to be 3/5. Okay. 3 over 5. The adjacent of hypotenuse, we take the adjacent, that's the one next to the angle. Okay, we have our adjacent over hypotenuse, that's going to be 4 over 5. Okay, and then for our tangent, that's going to be opposite over adjacent, that's going to be 3 over 4. Okay, so that's 3 over 4. There's three more ratios that we like to go deal with, and I always write them this particular way because it helps me remember what the relationships are. So the cotangent is the reciprocal of the tangent. This is adjacent over the opposite, or if you know that the adjacent is 3/4, or tangent rather is 3/4, the cotangent is simply the reciprocal of this. This is the 4 over 3. Okay. Secant is another angle that we use. This is the hypotenuse over the adjacent, or the reciprocal of cosine. This is equal to 5 over 4. And then we have the cosecant, which we abbreviate in this country as CSC. In other countries, it's different. Okay. They're going to say the adjacent, or the hypotenuse rather, over the opposite. And we're just going to say it's the reciprocal of the sine. It's going to be 5/3. And those are our 6 trigonometric functions that you're going to spend an awful lot of time with for the whole semester. A couple of things that I would urge you to do. Do a lot of homework where you have to write out all 6 trigonometric ratios and tell me what the numerical value is for that. When you write these trigonometric ratios, they must have an argument. If they don't have an argument, you will lose points. Your calculus teacher will maybe not execute you, but will come very close to taking a lot of points. Maybe they wish they did, but you will get you'll be punished for not writing out arguments in calculus. So, one of my jobs is to make sure you're writing out your arguments. Alex always puts the argument in there for you, so you don't get used to writing it. So it's a very easy trap to fall into. Don't let the computer, like, it's taking away that labor from you of writing in the argument. When you're writing it, make sure you're writing the argument. When I ask a problem, we're going to do one of these right next. Actually, let's go ahead and do this one. Let's go ahead and start with a triangle. So let's go with we have, you don't have to worry about the sides, like the actual length. Nothing is drawn to scale. Okay. So we're going to say this is going to be 9, we have 10, and then notice the right angle. We don't know what the hypotenuse is yet. It's our job to figure that out. And again, we're going to call this angle theta, and we're going to figure out the instructions will be like, what are the 6 trigonometric ratios for the angle of theta? This is like one of the first questions on your first test, and you're going to have to figure this out. So we're going to say, okay, it's a right angle. We're given that. So I know that this is going to follow Pythagorean's theorem. So we have a squared plus b squared equals c squared. So we're going to say this is going to be 9 squared plus 10 squared, right? That's 9 plus 10 is equal to c squared. And then we end up with 9 times 9 is 81 plus 100 is equal to c squared. So c squared must be 181, or c is equal to the square root of 181, right? So we're just going to go ahead and do that. Now, we're going to go ahead and sketch this in as 181. And then we're just going to write down the 6 trigonometric ratios here. So we have our sine is going to be 10 over the square root of 181, okay? The cosine of this angle is going to be the adjacent over the hypotenuse. It's going to be 9 over the square root of 181. The tangent is going to be the opposite over the adjacent, okay, which is going to be 10 over 9. That's fine. And then we have to figure out all 6 of them. So we have the cotangent of this angle is equal to 9 over 10. The secant of this angle is 1 over the cosine, so that's going to be the square root of 181 divided by 9. And then we have the sine of this, I'm sorry, not the sine, the cosecant of this angle. Okay, let's write that properly. So we can go ahead and write that down. So you can, oh, we don't want that one, we want this one. Get rid of all of that. All right, so we're going to say the cosecant of this angle is equal to the square root of 181 divided by 10. Okay. Now, there's one thing, if you're a trigonometry teacher teaching this, you're like, but you have to. I'm like, yes, I know, we're getting to that. One of the things that we don't like to do in trigonometry is leave radicals like the square root of 181 sitting there in the denominator. Okay, I'll show you why in a little bit. So the way we do this is there's 2 tricks in math. We can either multiply by 1 or we can add 0. We're going to multiply this by 1. I'm going to multiply by the square root of 181 over the square root of 181. This has, if we go through and do this, this is actually going to be 9 times the square root of 181. And when I multiply square root of 181 times square root of 181, we end up with 181. I know that these are relatively prime. They don't go into each other, so we don't have to worry about anything like that. Same thing over here. We're going to take the square root of 181 over the square root of 181. And then we're going to say this is 10 square roots of 181 divided by 181. And that would be how I'd really like to write my answers. Like that would be my answer. 10/9 is fine. There's no rationalization needed. The square root of, I'm sorry, 10 root 181 divided by 181. That's how we want to write our answer. Okay. So going back and remembering just the definitions of sine, cosine, and tangent, we have to say that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So a lot of times if you're taking trigonometry, the first word somebody will say to you is like, oh, SOHCAHTOA. So that's kind of like where we've took this mnemonic and shoved it together as a word. If you do a social media search for SOHCAHTOA, you will find a lady in California who goes absolutely berserk. It's very, very cringy to watch her go through SOHCAHTOA. One of the reasons why I don't particularly like the mnemonic is that I grew up with this, and I think it sounds like what white people think Native people sound like. Like that's terrible. I don't like to use this. You can use it. It's not, you're not being racist. You're learning trigonometry. Okay, so just realize that that's a thing. But if you go searching for it, I'm warning you now. It's cringy. Okay, but there we have it. Okay, let's talk about some very common angles. Okay, so that's the introduction to the trigonometric ratios. We're going to go ahead and we're going to do 3 angles that you're going to use, trig books use all the time. And we have very special triangles. So the first triangle we're going to deal with is we're going to take a box with side 1. This is a square. and we're going to make a triangle out of it, and we're going to figure out what is this hypotenuse. Well, we have one here, we have one here, we have a box, so it's a right angle here. So this hypotenuse is going to be, c squared is going to be 1 squared plus 1 squared. C squared is equal to 1 squared is 1, 1 squared is 1, so we have 1 plus 1 is 2. So c is equal to the square root of 2. Okay, so we have the square root of 2. Let me extract this triangle from the box and just work with the triangle. So we have our triangle. Okay, pretend that's a triangle. We have a square root of 2. We have an angle here, and that angle is either, we could say that's 45 degrees. We cut the 90-degree in half. We also know that that's pi over 4. Okay, that's just the radian measure of 45 degrees. As you were going through and doing your conversions, that's one of those things that you're going to find. So let's go through and do all 6 trigonometric ratios for pi over 4. So we're going to say we have sine of pi over 4. That's going to be the opposite. Remember, here's our eyeball. We're looking at our opposite, which is 1 over the square root of 2. We have cosine of pi over 4. That's the adjacent side divided by the hypotenuse. That's 1 over the square root of 2. And of course, we have the tangent of pi over 4, okay, which is going to be the opposite, which is 1 divided by 1. We have 1 over 1, which is 1. Now, then back in the day, and this is before my time, but back in the day, when engineers actually had to get numerical values for these numbers, what we'd have to do is we'd have to say, okay, we're going to do 1 divided by the square root of 2. Well, that's 1.414 and some change goes into 1, and we'd have to go figure this thing out. Now, as much fun as this long division promises to be, that's too much fun for one day for most of us. So this is why we do rationalize the denominator, is that we're going to multiply square root of 2 over square root of 2 and say this is a square root of 2. Square root of 2 times square root of 2 is 2. So if I had to get this numerical value, you would say, oh, that's 2 into 1.414 and some change, however fast you want to go do this. At least with this division problem, I know where to start. Okay, this one, I got to put a 0 point and I got to start adding a bunch of zeros. And this looks so fun. I'm going to let somebody else do it. This division problem, though, I think I could handle that maybe after the coffee on Monday morning, but I think I could handle this, right? We can start doing that. I know that you have calculators now. You never have to do this, but this is why that we did rationalize the denominators, is because numerically it was more efficient to do the problem this way than it was to do this long division. So I know that that's going back a few decades, and like, this is ancient history. Like, yes, it is. But there are still physics teachers, there's still engineering teachers, there are still math teachers that we learned this way. It was forced into us. So in the golden rule of do unto others as was done to you, we're going to make you do this too. So a lot of books, a lot of engineering teachers like you to rationalize denominators. So we will be rationalizing denominators for the most part. Sometimes we won't, but mostly we will. We'll just continue with this a little bit. We're going to say that the cosecant of our angle is going to be the reciprocal of our sine. That's going to be the square root of 2 over 1. No need to rationalize the numerator, just the denominators. The secant is going to be 1 over cosine, so we just flip the cosine. So we're going to say, okay, that's going to be the square root of 2 over 1. And then we have the cotangent, which is going to be the reciprocal of 1. So we end up with a 1. Okay, and I should probably have used the proper label for the angle here, which is going to be 45 degrees, or pi over 2, pi over 4 rather. So we can do that. So here we have pi over 4, pi over 4, pi over 4. Okay, and that's our angle for that one. We have another triangle to work with, all right? And that triangle is an equilateral triangle. So I'll go ahead and draw an equilateral triangle here. I'm going to make each side 2 because all the sides are equal, and it's my triangle, so I can decide how big I want to make it. We're going to make them 2. So each of the degrees here is 60 degrees, right? We have 3 angles. They're all equal, 180 degrees. So 180 divided by 3, we get 60 degrees. Or, so we can say this is 60 degrees, or pi over 3. And again, as you're doing your conversions from the previous section, you're going to recognize some of these things because this is an angle that's commonly used. The first thing I'm going to do, because this is not a right triangle, we can only do, right now, we can only do trigonometry on right triangles. You're stuck with just that. So I'm going to cleave this triangle down the center here. This is why I made them twos, is so I can divide the two into these two different parts, two equal parts, and we have one on each side. So I've got a little triangle here, okay, where I've got one on my adjacent side. I'm just pulling this triangle out here. This is going to stay one. The hypotenuse is going to be 2. And I have to figure out, what is this altitude? So we're going to say we have a squared plus b squared is equal to c squared. What's c? C is 2, so we're going to have 2 squared is equal to 1 squared, that's my adjacent side, plus b squared, and we just have to figure this thing out. So this is going to be 1 plus b squared is equal to 4, b squared is equal to 3, b must be the square root of 3. So this altitude is the square root of 3. Okay, remember this angle is pi over 3, or 60 degrees. This is what I'm looking at right here. There's my eyeball. We're going to look across. I'm just going to write down, what are the 6 trigonometric ratios for 60 degrees or pi over 3? So we can just start with that. So we have sine pi over 3. We have the square root of 3 over, it's my hypotenuse, 2. The secant of pi over 3, we're going to end up with adjacent side over hypotenuse. So that's going to be 1/2. And of course, we have the tangent of pi over 3, and that's going to give us opposite over adjacent, so that's just going to give us the square root of 3. Okay, now moving on, we have our cosecant of pi over 3, which is just the reciprocal of our sine, so that's going to be 2 divided by the square root of 3. Oh, we're not going to leave it like that. We're going to rationalize our denominator here right away, so we can say this is 2 root 3 over 3, and you're done. The secant, all right, of pi over 3 is just going to be the reciprocal of what the cosine was. That's going to be 2 over 1. Okay, the cotangent of pi over 3 is going to be adjacent over opposite. Again, we go back up here. Adjacent over opposite, we end up with 1 over the square root of 3. But here we have a radical in the denominator. Let's fix that by multiplying by 1. So we end up with the square root of 3 over 3. And that is our trigonometric ratios for the angle 60 degrees or pi over 3. Okay, I'm going to go back up to this triangle. I'm going to tilt it on its side because I know this was 30 degrees. If I cut this angle in half here, right, or this was 60 degrees, sorry, this is 60 degrees. This angle up here is going to be 30 degrees, right? That's pi over 6. So let's go ahead and pluck that triangle out. Okay, and I'm just pretty much using the same triangle. I've cut it in half. Remember, this was 1, this side was 2, and my altitude, which is now my adjacent side, is the square root of 3. And then we know that this guy right here is going to be 30 degrees or pi over 6. Okay, again, from doing the conversions, it's one of those angles that you're just going to get to know over and over and over again. And we're just going to we want to do the sine, cosine, and tangent of our 30 degrees here. So we're going to say we have our sine of 30 degrees. That's going to be our opposite over hypotenuse. So that's going to be 1/2. Okay. Our cosine of 30 degrees was going to be the square root of 3 adjacent over hypotenuse, square root of 3 over 2. All right. Our tangent of 30 degrees is going to be opposite over adjacent. So that's going to be 1 over the square root of 3, but we're not going to leave it like that. We're going to go ahead and rationalize the denominator and end up with a square root of 3 over 3. Okay. And then we have to do our reciprocal functions. So the cotangent of pi over 6, which is the same as 30 degrees, just going to flip this guy on its side, or flip this guy on its head, and say this is going to be the square root of 3, sorry about that, over 1. The secant of 30 degrees, or pi over 6, is going to be 2 over the square root of 3. And again, we're going to rationalize our denominator. Okay, and that's equal to 2 root 3 over 3. Right? And then finally, we get to our cosecant of 30 degrees. Let me go ahead and make that a 30 degrees there. All right. Pi over 6, same thing as 30 degrees. And that's just going to be 2. So Those are very typical angles. When you tell somebody you're taking trigonometry, if you go to the tutoring center at our library, the first thing they're going to do to you is they're going to hand you the unit circle where you have to memorize all of the different angles, which is all of these angles, okay, for all the trigonometric functions for it. And that's what they're going to do with you, okay? That's okay. It's a lot to memorize. I'll show you a trick to memorize this thing, and we'll go ahead and deal with that, okay? So I'm going to write down our angle. And then here we're going to have our sine and our cosine. So we have our sine and our cosine. We have a 0-degree angle. We have a pi over 6 or 30 degrees or 45 degrees or pi over 4. Let me go ahead and make it consistent with our table here so we can go ahead and make that happen. So we have 45 degrees or pi over 4, right? Or we have pi over 3. Right? We have 60 degrees or pi over 3. And then we have 90 degrees, pi over 2. All right. Now, the first thing that we're going to do is we're going to deal with this 0 degrees. Okay. So I'll come down a little bit. We're just making a little bit of a thing over here. We'll say, okay, sorry, I'm going to stop you for just a moment. Here you go. Pause. Okay. The alarm. So we have our triangle, and what we're going to do is pretend that we have an angle sitting here, okay? Whatever angle this is. Here's my opposite, here's my, and here's my hypotenuse, okay? For an angle of 0 degrees, what I'm going to do is we're going to take this angle, we'll do green. No, we won't, because I can't see that. We'll do purple. Okay. What we're going to do is we're going to shrink this angle down. I want to make this angle 0 degrees, which is going to do, what that's going to do is it's going to make this triangle smaller and smaller and smaller and smaller. My opposite side here is shrinking down, pushing it down, I'm squishing it all the way so that this opposite side is kind of almost, it is actually 0. So the sine of 0 degrees or 0 radians, I'll say 0 degrees or 0 radians, right? The degrees would be the 0 degrees, or radians is just 0. It's going to be 0 over my hypotenuse. We're always going to make my hypotenuse 1, okay? So we're going to end up with that. So here we have our sine of 0 is going to be 0, okay? We also have to do the sine of 90 degrees. Let's look at what that looks like. Okay, so I've got again, my triangle here. Here's my angle. So as I'm looking at this, what I'm going to do is I'm going to try to get my angle to be 90 degrees. So instead of this angle, we're going to move this side in further and further and further and further. So we're going to go here and here and here and here. I'm just squishing the two sides together so that as I have my angle sitting here straight up, my opposite side, technically, is still going to be 1 over my hypotenuse. So the sine of 90 degrees, the sine of pi over 2, is opposite, which is 1 over my hypotenuse, which is 1. So it's 1. Okay, so we've squeezed the adjacent side to 0 because we've squeezed it together here. Okay, the opposite side stays to be 1. Okay. In this case, as I squeeze this triangle down, the adjacent side becomes 1. The opposite side shrinks to nothing, but the adjacent side pretty much stays at a 1 here. So we're going to go back to blue, and we will talk to you about the different pieces here. So the sine of 0 is 0. We're talking about, here's my sine of the angle, opposite over adjacent. Remember, what was pi over 6? We can go back up a couple of pages and look at it, but that was 1 over 2. Pi over 4, that was the square root of 2 over 2. Pi of 60, or sorry, sine of 60 degrees is going to be the square root of 3 over 2. Just look about a page up. And then we just did the sine of 90 degrees is 1. And you're looking at these and I'm like, that's not really that helpful. And I'll say, yeah, I know. But notice that these are all divided, all of these guys are divided by 2's. A fancy way to write 0 is to say that's 0 over 2. We have 0 over 2, 1 over 2, square root of 2 over 2, square root of 3 over 2. And then a fancy way to write 1 is going to be 2 over 2. But it's still got all these square roots. Like, yeah, it's not quite good enough for the pattern, right? Because there's square roots that you got to deal with. But you know what the square root of 0 is? 0. So we could say this is the square root of 0 over 2 is the same as 0, which is the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2. The fancy way to write 2 is 4, right? The square root of 4. So we could say that instead of 2, we're going to say the square root of 4 over 2. That's really 2 over 2. So to get our angles for sine is going to be square root of none over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Cosine counts backwards. So with cosine, we know that the cosine of 0 degrees, I'm looking at my triangle of 0 degrees, right? The adjacent side is still 1, so we end up with 1 over 1. Well, how did we write 1 before? We wrote it as a square root of 4 over 2. Go back up a couple of pages, you could say, oh, it is the cosine of 30 degrees. Oh, that's the square root of 3 over 2. Cosine of pi over 4, square root of 2 over 2. And of course, the square root of 60 degrees is going to be the square root of 1 over 2. And then as I look at my triangle for 90 degrees, the adjacent side shrank to 0 because we squished the triangle together and made that adjacent side 0, and that is the square root of none over 2. Right? So that's an easy way to memorize these easy triangles. Uh, I'm not going to quiz you on this. I'm not taking your calculators away from you. You will always have your calculator with you. So like asking you what the cosine of 30 degrees is going to be, you will be able to tell me what that answer is. Now, you'll recognize the decimals for these as you do more and more and more of them. You're like, oh, root of 2 over 2, that's 45 degrees. That's 0.77071. Like you will start to just recognize this number. When I took trigonometry, they told me you're not allowed to use a calculator. You had to memorize these. It's the 21st century. They're like, you want to have a phone? You want to have a calculator in your pocket? I'm like, I think we do have calculators in our pocket all the time now. So I'm not going to take yours away, but I will tell you that your engineering teachers will be more proud of you if you know that sine and cosine of 45 degrees is square root of 2 over 2, and you can just rattle that off. So you don't have to have these memorized, but as you're doing the problems, try to pay attention to what you're doing so that when it does come time for you to like, oh yeah, I should have memorized that, it won't be that much of a leap for you to memorize it. So just try to pay attention with the knowledge that someday you will have to memorize this. Okay, what about tangent? What about the tangent? Let me go ahead and do this and say, okay, tangent is, I'll go back to this table, but let me just take a little bit of a break here. So tangent, right, is equal to the opposite over the adjacent. And I wrote it as kind of a big fraction because I'm going to multiply by 1. So really, yeah, I'm going to multiply by 1. And the one I'm going to pick is, I'm going to say is this 1 over the hypotenuse divided by 1 over the hypotenuse. 1/3 divided by 1/3. That is still 1. We can agree to that. So 1 over hypotenuse divided by 1 over hypotenuse, that's still 1. I'm still multiplying by 1. And then we could say, okay, well, how do we arrange this fraction, right? How do we evaluate that? That's going to be opposite over hypotenuse divided by adjacent over hypotenuse. And I could swear that I told you what opposite over hypotenuse was before. That's sine of an angle. Adjacent over hypotenuse, I could swear we talked about that before. That's a cosine of the angle. So tangent is simply the sine over the cosine. That is a relationship that you're going to have to memorize. There's a couple of things you have to memorize. But that's one of those things you have to memorize because that comes up over and over and over again, and we're going to use that. We're going to use that right here because we're going to say sine divided by cosine. We have 0 divided by 1. Well, 0 divided by 1, that's just 0. So the tangent of this angle is 0. Here we're going to have, what is the tangent of pi over 6? The tangent of pi over 6, we're going to get 1 divided by 2, that's my sine, divided by the square root of 3 over 2. Do you remember learning how to use division by fractions? Of course you did, like it was yesterday. So we have 1/2 times 2 over the square root of 3. The 2's cancel. We get 1 over root 3. We're not going to leave it like that. We're going to say that's square root of 3 over 3. So that's going to be the square root of 3 over 3 here. So we end up with square root of 3 over 3. Okay? Square root of 2 over 2 divided by square root of 2 over 2. I'm pretty sure even without coffee, I could say that's 1. And then for the tangent of 60 degrees, we have the square root of 3 over 2 divided by 1/2. Again, remember how you go ahead and deal with this. That's the square root of 3 over 2 times 2 over 1, right? Invert and multiply when you divide. The 2's cancel. We end up with square root of 3. So here we go, square root of 3. Now here's the problem. We have sine over cosine. We have 1 divided by 0. Well, that's undefined, right? 1 divided by 0 is like, well, pick what you want this to be. Like, okay, I'll pick that it's going to be 0. If I undo my division and multiply both sides by 0, technically I would cancel, right? If I'm following basic algebra rules here, we're not because this is undefined, but you'll see why in a second. I'm going to say 1 is equal to 0 times 0. You're like, that doesn't seem right. No, it doesn't. That's why it doesn't work. So we're going to say this line is undefined because we're divided by 0. All right. We'll talk a little bit about that later in the course. So it will still be undefined, but you'll have a more of a intuitive sense about what's happening to this, okay, as we go through it. But that is your basic trigonometric ratios. That's your basic trigonometric ratios for the basic angles, which are these guys, and you have a way to memorize them. So I think that is plenty to talk about for one lecture. I'm going to let you go with that, and we're going to say thank you very much for watching, and I will see you on the next video.